Determine all intervals of increasing trend or decreasing trend and determine the coordinates of all maxima, minima, plateaus, or cliffs for the function f of x equals 8 minus 48x plus 8x squared plus 4x cubed minus x to the fourth. The first thing to do is find the domain. F of x equals 8 minus 48x plus 8x squared plus 4x cubed minus x to the fourth, which is a polynomial, and a polynomial has a domain of all real numbers, or negative infinity to positive infinity. The next thing to do is find all critical numbers. We will take the first derivative. F prime of x equals, first term is a constant with no x, derivative is 0. Second term is a constant times x, derivative is the constant. Third term is power, row bring down the power, multiply with the 8, subtract 1 from it. Fourth term is power, row bring down the power, multiply with the 4, subtract 1 from it. Fifth term is power, row bring down the power, multiply with the negative 1, subtract 1 from it. We will want to fully factor the first derivative. This is a 4-term cubic here. We could attempt to factor by group factoring. We can group together the first two terms, though we will want to write it in descending order to make the group factoring a little easier. So the 16x first, then the negative 48. We can group together the second two terms, again, descending order, negative 4x cubed first, then the 12x squared. The first group has a common factor of 16. Factoring that out will leave behind an x minus 3. The second group has a common factor of a negative 4 and an x squared. Factoring that out will leave behind an x minus 3. Since the x minus 3's match, group factoring is possible. And we can factor the x minus 3 out of the entire expression, which leaves behind a 16 minus 4x squared, which has a common factor of 4. That can factor out, it will move to the front of the entire expression. And that'll leave behind a 4 minus x squared, which is a difference of squares and can further factor into 2 plus x and 2 minus x. We can now set the numerator equal to 0, and the denominator, if there is one, also equal to 0. And solve for all x's. This will give x equals 3, x equals negative 2, and x equals positive 2. We will now check to see whether these are in the domain. The domain is all real numbers here. These are each real numbers. They are all in the domain. We keep all of them. They are all critical numbers. We will now draw a domain line. The domain is negative infinity, so it has no left end, to positive infinity, so it has no right end. We can put the critical numbers on the domain line in order. Negative 2 is the lowest. Then a positive 2. Then a positive 3, which breaks the domain up into 4 intervals. We can pick a test value in each of the intervals. The first interval, negative infinity to negative 2, contains negative 10. The next interval, negative 2 to positive 2, contains 0. The next interval, 2 to 3, does not contain an integer, but 2.5 is in there, which is 5 halves. The next interval, 3 to positive infinity, contains 10. We can now test the trend in each of these intervals by plugging the test value into the first derivative. We do not care about the value of the first derivative, just whether it is positive or negative here. So the best place to plug in would be the fully factored version. If we plug a negative 10 in, negative 10 minus 3 is negative, 2 plus a negative 10 is negative, 2 minus a negative 10 is 2 plus 10, which is a positive. Negative times positive is a positive, times the positive 4 is still positive. We have a positive first derivative, which corresponds to an increasing trend. Plugging a 0 into the fully factored version, 0 minus 3 is negative, 2 plus 0 is positive, 2 minus 0 is positive, negative times positive is negative, times the positive 4 is still negative. We have a negative first derivative, which corresponds to a decreasing trend. We can now plug a 5/2 test value in. 5/2 is greater than 2 and less than 3. That'll help out for plugging it in to the fully factored version. 5/2 minus 3 is negative. 2 plus 5/2 is positive. 2 minus 5/2 is negative. Negative times negative is a positive, times the positive 4 is still positive. We have a positive first derivative, which corresponds to an increasing trend. And now we can plug the positive 10 test value in. 10 minus 3 is positive. 2 plus 10 is positive. 2 minus 10 is negative. Positive times negative is negative, times the positive 4 is still negative. We have a negative first derivative and a decreasing trend. So we have an increasing trend on the interval of negative infinity up to negative 2, union, and then it happens again in the interval from 2 to 3. We have a decreasing trend in the interval negative 2 to positive 2, union, and then again from 3 to positive infinity. At the critical number of x equals negative 2, the trend is changing from increasing to decreasing, which means that there is a relative maximum at x equals negative 2. So it has an x-coordinate of negative 2. It'll have a corresponding y-coordinate that can be found by plugging the x-coordinate into the original function. So the y-coordinate will be f of negative 2, which will be 8 minus 48 times negative 2, plus 8 times negative 2 squared, plus 4 times negative 2 cubed, minus a negative 2 to the 4th, which is going to be 8, and then a negative 48 times a negative 2 is a positive 96. Negative 2 squared is a 4 times the 8 is a positive 32. Negative 2 cubed is a negative 8 times the 4 will be a negative 32. And a negative 2 to the 4th will be a positive 16 times the negative will be a negative 16. The 32's can cancel. 96 minus 16 is an 80, and then add the 8 on is probably the easiest way to combine them. And that will give an 88. So there's a relative maximum at negative 2, 88. At the critical number of x equals positive 2, the trend is changing from decreasing to increasing, so there is a relative min. An x-coordinate of positive 2 and a y-coordinate that can be found by plugging the x-coordinate into the original function. So y will equal f of 2, which is 8 minus 48 times a positive 2, plus 8 times a positive 2 squared, plus 4 times a positive 2 cubed, minus a positive 2 to the 4th, which is 8. A negative 48 times a 2 is a negative 96. 2 squared is 4 times an 8 is a positive 32. 2 2 cubed is an 8 times a 4 is another positive 32. And then 2 to the 4th is a 16 times the minus will be a minus 16. Eight minus 96 is a negative 88. Plus a 32 is a negative 56. Plus another 32 is a negative 24. And then minus 16 is a negative 40. So a relative min at 2 comma negative 40. The last critical number, x equals 3, has a trend increasing on the left, decreasing on the right. That again is a relative maximum. So there's another relative maximum with an x coordinate of 3 and a y coordinate that can be found by plugging it into the original function, which will be 8 minus 48 times 3 plus 8 times 3 squared plus 4 times 3 cubed minus 3 to the 4th, which will be 8. A minus 48 times a 3 is a negative 144. 3 squared is 9 times an 8 is a 72. 3 cubed is a 27 times a 4 is a 108. And then a 3 to the 4th is an 81 with a minus. 8 minus 144 is negative 136. Plus a 72 is a negative 64. Plus 108 is a 44. And then minus 81 is a negative 37. So we have a relative maximum also occurring at 3 comma negative 37. So we have 2 relative maxima, negative 2 comma 88 and 3 comma negative 37, and 1 relative minimum at 2 comma negative 40.